Plastic. Everyone knows this word. Even in the university group, we can't go anywhere without seeing any plastic waste. Today, it is difficult to imagine any aspect of human life to be untouched by plastic. Its versatility and low cost have embedded in every corner of our modern world, from packaging and agriculture to healthcare and technology. Globally, about 380 million tons of plastic are produced per year. From 1950 to 2021, about 8.3 billion tons were produced, of which only 9% was recycled and 12% was incinerated. About 12 million tons of plastic ends up in the world's ocean each year. There is already a garbage island in the Pacific Ocean that is 3 times the size of France. Plastic is a practical threat to nature because naturally it breaks down very slowly. Even though its durability is convenient, once discarded it becomes a curse. The degradation process of plastic is slow and it results in fragmentation rather than complete mineralization, which means that it still remains in the environment for many years, poisoning and polluting all living things. The main problem of plastic pollution on the planet is microplastics. I'd like to remind that microplastics are particles of plastic smaller than 0.01 to 5 millimeters, which are distributed all over the world. They are easily ingested by various organisms, passed along the food chain from one creature to another, circulating almost endlessly in the environment. Studies are finding particles in the most remote locations, from the peaks of Mount Everest to the depths of the Mariana Trench. It gets into the air we breathe, the water we drink, the food we eat. Today we will visit the Center of Research of Microplastics in the Environment. There is a wide variety of research being conducted here to study this problem. Let's find out exactly how researchers obtain the data for their work. First, let's choose a subject we want to examine. For example, sea urchins. We'll separate the organs we are going to test their microplastics content and put them in a bath of alkaline for a few days at high temperature. We also can't forget about the control sample to prevent microplastics from the outside from interfering. Then we'll add salt to increase the density of the solution so the plastic particles float to the surface. Then we wait a little longer, and finally, filter the top of the solution with microplastics using a vacuum filter. Our sample is ready! Now what remains is only to look at the result in the microscope and count the number of particles. Microplastics, when ingested, have a complex effect. First, it can enter the bloodstream from the stomach and intestines and spread throughout the body, accumulating in the liver, kidneys, and the other organs. Upon entering the lungs, for example, microplastics can cause mechanical damage and inflammatory reactions. Once accumulated in the body, microplastics can have carcinogenic effects and lead to cell mutations and neoplasms. Also, microplastic is an absorbent, meaning it is able to absorb substances in which it is located. For example, in seawater, microplastic absorbs polychlorinated biphenyls, chemicals which can lead to cancer. It may also contain the dangerous element bisphenol A, which is similar in its properties to the female hormones and can damage the human nervous and reproductive systems. Small amounts of microplastics will exit the body on their own, but most of it will remain, so the only way to deal with it is to prevent it from entering environment. If we want to reduce contamination, the following important steps should be taken. Reduce the usage of disposable plastic products. Improve the plastic waste disposal and recycling system. Develop more environmentally friendly alternatives for plastic materials. Increase public awareness of the harms of microplastics and the need to take action to reduce them. Everyone has the power to do the fight against the small but dangerous particles. And remember, it's not the Earth that needs saving, but us, its population.